All right, Algebra 1, welcome back. Let's talk about a couple of things here before we start the last method of solving systems of equations. So first of all, we started off with looking at graphs. So we were given something like this, and then we basically, from this, we looked at this and just found the point where the two lines intersect. And that is the main idea behind solving systems of equations, whether it's by graphing, where you graph the lines, which we'll get into later on, graph the lines and find the point where they intersect, or substitution, which I'll go through this problem, or what we're doing today is elimination. We'll have this. We'll spend a few days in elimination as well. So these are these two lines. So this top line here is the red one, and the bottom line is the blue one. I just graphed them, took a screenshot, and put it on here to show you that these two lines intersect at -1, -1. Okay, and when we go through and do this problem, you'll see that our answer is -1, -1, because we need to keep that in the back of our mind, that the point where these two lines intersect is the solution to the system of equations. That's why we always write our answer as a point. So let's run through this here real quick. So first of all, again, one of our problems, one of our equations will be, if we're solving by substitution, one of them will be equal to a variable. So what we do is we take what it's equal to, in this case y is equal to 4x plus 3, and we plug that into the other equation for that variable. So we're going to plug that into here for y. So I took x plus y equals -2, that bottom equation, and I replaced, or I substituted in for this y, what I know about y, and I know that it's equal to 4x plus 3, and I did that so that I was left with an equation that had only x's that I could actually solve. So here, if there was anything outside here, we would distribute it through, but there wasn't. I mean, there's a 1 there, but that doesn't change anything, so I brought down the x, plus 4x plus 3, I just brought that down, equals -2. Then I combined my like terms, so I said x plus 4x right there gives me 5x. I brought down to plus 3 equals -2. And then I started moving stuff around. This was a positive 3, so I did the opposite and I subtracted 3. 3 minus 3 is 0, so those are gone. I brought down the 5x. -2 minus 3 is -5. And then my last step, I divided both sides by 5 to get x by itself. -5 divided by 5 is -1. So then what do we do from here? Well, we go back to our other equation. And the reason why we use the other equation is because it's already solved for y. So this is a much simpler equation to solve. So I go back to that other equation and I plug in what I know about x now. I know that x is -1. So I substitute in for x -1. And then I go through and solve that. 4 times -1 is -4. Plus 3, -4 plus 3 gives me -1. So you can see my final answer here is -1, -1. Which I knew because I graphed and I could see that they intersected right here at -1, -1. All right, so I'm just pulling all this stuff together here to show you what is happening. Now, this is the substitution method because we took an equation and we substituted it into the other equation. What we are doing now is the elimination method, and the elimination method, just what it tells you, you have to eliminate a variable, okay? So we're going to do this in 3 separate days of notes at least, and then a couple days of practice mixed in there. So, excuse me. Now, you have to make sure that these are organized in your what's called standard form. So x first, and then y, and then equals to a number. So you want x and y by themselves on the left, and then the other number on the right. So the next thing that we're going to do is we're going to try to eliminate one of the variables, and you need 3 things to do that. You need the same number, okay? We need to have the same number in front of it. Like, so let's say we decide to eliminate x. We need to have the same number in front of x, okay, in front of the same variable, so like a 2x and a 2x. But then one of them has to be, they have to be opposite signs, so one positive and one negative. So same number in front of the same variable with different signs. Okay? And again, what this is saying, eliminate the variables that are opposite. That just means like a 2 and a -2, or a 5 and a -5, or something like that. So then what we do is our equations will already be set up into columns. We will add the rest of the columns in the system, and then we'll solve. And again, in doing this, we will be left with one variable. All right, so let's go through an example, and I think it'll make a lot more sense. So if we look at this, we can clearly see same number in front of the same variable with different signs. Look at your x's. What do we have? Negative 4x and a positive 4x. Same number in front of the same variable with different signs. One's positive and one's negative. So what do we do from here? Well, basically all we're going to do is we're going to take excuse me, and add these columns. Okay, so add the columns. Negative 4x plus 4x is 0. Those are gone. Negative 2y plus 8y is 6y equals, add these together. Negative 12 minus 24 is a negative 36. And again, you're always left with another equation that only has one variable. That's always your goal. Whether you're using substitution or elimination, your goal is always to get down to the point where you have one variable left. Now, how do we get rid of the 6? Well, it's being multiplied, so I will do the opposite and divide. So I'm going to divide both sides by 6. And then what am I left with? Y equals negative 6. Now, in the elimination method, the first step is always the easiest. If I go back to substitution, you can see the first step is always the most work, and then the second step is pretty easy, like doing this part over here. This is always easier to do the second part. In elimination, the first part is easier and the second part takes a little bit of work. But it's still not that terrible. So now, what do? Well, what we're going to do is we're going to take one of these equations. It does not matter which one. Take your pick. I like the bottom one, so I'm going to take 4x plus 8y equals negative 24. And I'm going to now take the negative 6 down here, and I'm going to plug that in here for y. Okay, so I'm going to take that. Let me erase this. I'm going to take that, and I'm going to plug it in here for y. So what do I have? Well, I got a 4x plus 8 times, I know y is negative 6, I just solved for that, equals negative 24. So let's solve this now. 8 times negative 6 is negative 48, equals negative 24. And now we have a two-step equation. So add 48, this is a negative 48, so we have to do the opposite and add 48 to both sides. Okay, and they cancel. Left-hand side is 4x equals the right-hand side negative 24 plus 48 gives you a positive 24. So last step, divide both sides by 4 and we get x equals 6. So my final answer is x is 6, y is negative 6. Okay? Now me personally, I think the elimination method is easier. That's why I do substitution first, because I think it's more challenging and I want to get that out of the way first. So personally, I think elimination is easier. Hopefully you feel the same way too, and these problems aren't too bad. So let's move on to the next one. Again, same number in front of the same variable with different signs. Do you notice something here? Do we notice something? Well, my x has this is a 1x and this is a 2x. This one is a negative 1 and this one is a positive 1. So negative 1 and positive 1, that means the y's will cancel. So add every column. X plus 2x is 3x. Y plus y is 0. So equals 11 plus 19 gives me 30. So now divide by 3. This is 3 times x, so I do the opposite and divide. Divide both sides. Man, what is going on here? Tablet's not cooperating today. So divide both sides by 3 and I get x equals 10, right? 30 divided by 3 is 10. So now take that and plug it into the other equation, one of the equations, doesn't matter which one, plug it into one of the equations for x. I'm going to use the second equation again, let's see what we get here. So 2x plus y equals 19. This is what I'm going to use. So 2x plus, I know that x is 10, so I'm going to say 2 times 10 plus y equals 19, okay? I know that x is 10, so I plug that in for x. So 2 times 10 is 20, plus y equals 19. Subtract 20, we need to move that over, so subtract 20 from both sides. And I get that y is equal to -1. So there is my answer. X is 10. Oops, let me rewrite that. Parenthesis looks kind of funny. So my answer is 10, -1. The x is 10, y is -1. And again, your x value always has to go first in your answer. Okay, next. Again, look at your problem, okay? So we can see here that the x's will cancel out. I have a -6 and a +6. So when I add the columns, -6x plus 6x is 0. 5y plus 4y is 9y, and 1 minus 10 is -9. Divide both sides by 9 to get your y by itself. Y equals -1. Plug that in to the other equation, or plug that into one of the, it doesn't matter which one, take your pick. Plug it into one of them. I'm going to use the top equation this time because I used the bottom equation the other 2 times. So -6x plus 5y equals 1. So let's plug that in here. -6x plus 5 times y I know is -1. Okay, I just solved it down here. I just solved and I got y was -1. So, oops, -6x, 5 times -1 gives me -5 equals 1. Keep going. Now I need to move the 5, so I have to add 5 to both sides. The 5's cancel out, right? -5 plus 5, these are gone. So -6x equals 1 plus 5. Let me erase this here, clean it up a little bit. The right-hand side, 1 plus 5 is 6. Last step, divide both sides by -6 to get your x by itself. We get x equals -1. Final answer, oops, -1 for the x, -1 for the y, and that's our final answer right there. -1, -1. All right, a couple more here. 4 and 5, 2 more left to go here. So now, I wanted to throw in one of these problems here and show you something that we've already talked about. So maybe you recognize, hopefully you recognize it, but what happens when we add these columns together? Well, I have 3x minus 3x, which is 0, -7y plus 7y, which is 0, so my entire left-hand side is 0. And then the right-hand side is 19. Well, that's false. 0 is not equal to 19, right? Hopefully we can obviously see that. So what happens when we have a false statement? No solution. Okay? Remember, if it's false, that means no solution. If it's true, it's infinitely many solutions, and we write IMS. So let's see what we have here. Well, we have a little bit of work to do because it's not in standard form. The bottom equation is not in standard form. So let's start off by rewriting, excuse me. Let's start off by rewriting that top equation here. So I'm going to put my little squiggly bracket there. -2x minus 4y equals -8. Now, coming back over here, I have to add 2x to both sides because it's not in standard form. So we need that x. Remember, we want this to be in the form of, let me come up here, ax plus by equals c. So if it's not in that form, we need to put it in that form to start off with, okay? So I'm left with now 2x plus 4y equals 8. So let me plug that in over here into my equation. So 2x plus 4, let me try again. 2x plus 4y, there we go, equals 8. What happens when we add these columns together? Well, I get a 0. I get a 0, so this whole left-hand side is 0. And then over here, I get, again, -8 plus 8 is 0. So now this is a true statement, which means my answer is IMS. okay? So again, there's 3 problems where you actually had to go through, solve, and get a point for an answer, and then I wanted to, again, just come back to that whole no solution IMS concept for those last 2 problems. So again, today, all of them will be set up for you. So all you have to do is recognize the variable that has the same number in front of the same variable with different signs, add the columns, and you get your answer. The next day of notes, we'll have to do a little bit of work. So right now, these are already set up for you. So again, like always, if you have any questions, please let me know.